Hi everyone. Today we're doing a pure paper, pure 1. So we start off with one of these binomial expansions. So you may recall that there's various ways of expanding a function, but if you have some bracket to the power of a positive integer, you can expand it exactly in some finite number of terms, and that's all given in your formula booklet. So so this is just binomial expansion, and it looks something like, well, they only care about the coefficient of x, the coefficient of x squared. So usually binomial expansion, you'll have some f of x is going to be equal to some constant, your initial value, plus, in this case, 7 choose 1, and then times 2 to the 6 times ax. So this is all just plugging in stuff from here into the formula in the formula booklet. And then there's plus 7 choose 2. Oops, should not be a line there. That's a 7 choose 2. 2 to the 5 ax squared. And now you told that, and there's obviously infinite about 4 more terms, but you just told that these two terms are the same. Or rather, sorry, that the coefficients are the same. So ignoring the x, the coefficient is just the thing in front of the x. So 7 choose 1, 2 to the 6 times a is equal to 7 choose 2, 2 to the 5 times a squared. And you can you can use this to solve for a. And you're told that a is non-zero. Therefore, you can divide by a on both sides. And then this a, you just take all this stuff over and you solve for a. And that's all there is to it. So it's just plugging into the binomial expansion in the formula booklet. Okay, this one's also pretty straightforward. So you can use your calculator for this. So you just take the sine of both sides, and sine and inverse sine cancel out. So you get x minus 1 is the sine of the tangent of 3. And therefore x is equal to that plus 1. That's really, it's like it's a 2-line problem. 3 marks, but you sorted. Okay, so this one's just also trigonometrics, but it's just a little more involved. But you have to essentially just use the formulae for the trigonometric functions that are in your formula booklet. So first, I'm going to bring this cosine into this fraction. So I go 13 sine squared theta plus cosine theta times the denominator, 2 plus cosine theta, all over 2 plus cosine theta is equal to 2. Now I'm going to multiply both sides by 2 plus cosine theta. So I get 13 sine squared theta plus 2 cosine theta plus cosine squared theta is equal to 4 plus 2 cosine theta. 2 cosine theta on either side cancel out. And then I remember that sine theta is equal to, the sine squared theta is equal to 1 minus cosine squared theta. That's just in the formula booklet. So I get 13 minus 13 cosine squared theta plus cosine squared theta is equal to 4. And then I just rearrange, and I get that 12 cosine squared theta is equal to 9. And this gives you that the cosine of theta is equal to plus or minus 9 over 12. So there's 2 possible values that cosine theta can equal. So you have to account for both of these. You're told that theta lies within the range 0 to 180 degrees. So let's look at the cosine function. And it looks something like this, where that is 360 degrees. So this is 180. So we're just interested in this section. And plus square root of 9 over 12 is somewhere there, and minus is somewhere there. So you've actually got 2 values of theta, which will give you a cosine of theta being one of these options. So if you plug into your calculator, you'll get this value. Sorry, this one. And you also need that one. So you'll get some theta naught, and you'll realize that the other value is, in fact, you can just plug it into your calculator, but take the inverse. So the first value of theta is going to be equal to inverse cosine of plus square root 9 over 12, and the second value is going to be equal to minus square root 9 over 12. And that'll give you the answer. So you don't actually need to worry too much, but your calculator will tell you. So just remember to keep both of them. They're both required. Okay, question 4. So we have some equation of a line. It looks, a little bit different, but really it's just a y equals mx plus c line. All lines have the form y equals mx plus c, but they've just done it a little differently. They've rearranged or something, so you get something that looks like this. And you're told 2 points that are on the line, and you're asked to find the values of k and b. So you have 2 unknowns, and you have 2 equations. So for every unknown you need an equation. So our first equation is this line with a plugged in, and then the second equation is the line with b plugged in. So I'll show you the a one. So 4 times the x value of a plus k times the y value of a is equal to 20. And this will give you k, and then you plug in 4 times b plus k times whatever your k was, 2b is equal to 20, because these are both on the line, so they both obey that equation. And this will give you a value for b. Now, they want you to find the coordinates of the midpoint of AB. Now, this is a very common problem. Is just that you should just get used to the idea of what a midpoint is and how to find it from these are basically vectors, 2-dimensional vectors. So A I could say, I could express as, also you could call it OA, that's another way, same thing. And that could be equal to 8 minus 4, and B equal to B2B, whatever your B was. And so this coordinate is basically indicates a line from the origin to A, and this one a line from the origin to B. And you want the midpoint of this line from A to B. Well, the line from A to B, this is the origin. If I want to get from A to B, but I only know how to get from the origin to A or the origin to B, well, I can just go back from A. If I'm starting at A, I can go back to the origin, which is expressed as minus A, and then I go from the origin to B plus B. So that's just the equation for this line. Now, what if I want to go to some midpoint M? Well, to get to M from the origin, so you can think of this as OM, I want first to go to A and then just halfway down this line. That's the midpoint of the line, right? So I go to A, and then I go halfway down AB. And that's it. That's how you find the equation of the line, of the midpoint. So you just use your values here and calculate these two steps. Question 5. Okay, so again, we've got some equations. We've got the equation of a line in the old y equals mx plus c format, and the equation of a curve, which you should recognize as a parabola because of this x squared. So we're going to have a parabola and a line, and they're going to, we want them to meet at 2 distinct points. Well, this is a condition which depends on the value of the discriminant. And what is the discriminant? Well, when I have some line y defined by y1 and some curve or another line or something defined by y2, if I set them equal to each other, I get an expression in x, and then I solve for when I solved for the values of x to satisfy that equation. So you'll get something in terms of like x squared plus ax squared plus bx plus c is equal to 0. So you should be familiar with this procedure. And then you solve using the formula. So let's do that. So let's say 2x minus k is equal to x squared plus kx minus 2. That is me setting these two values equal to each other. I mean, the reasoning behind that is that we're looking for points which lie on both lines. So the x and y values of those points will satisfy both equations. So the y at those 2 points, and only at those points, like not anywhere else on the curve, some other random point on the curve will not satisfy the equation of the line because it's not on the line. But at these specific points, though that y value is equal to that y value because it satisfies both of these. Therefore, whatever's behind the y value, those things are equal. So let's put this into standard form. X squared plus k minus 2x plus k minus 2 is equal to 0. And for this, so this is so a is equal to 1 from this guy. B is equal to the same thing as c, which is equal to k minus 2. And if you remember the formula, which should be engraved on your heart, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This thing inside here, this is the discriminant, del. And del decides how many places that the two curves meet. Point. So you see that there can be different possible x coordinates. So there's this plus or minus. So you'll get a different one if you take a plus or a minus. If del is greater than 0. So if del is greater than 0, then you're going, so let's just separate this. So minus b over 2a, that's always going to be the same. But then you have plus or minus the square root of del over 2a. So if del, let's think of the case where del is equal to 0. If del is equal to 0, then this whole thing is 0. So both x values are minus b over 2a. There's going to be no difference whether you take the plus 0 or minus 0. So therefore, both x values will be the same. This is the case where the thing just touches at one single point. So you can kind of think of it as like two crossing points, but they're both in the same place. It's essentially one crossing point. So that is tangent. So that's when your line is tangent to the curve. If del is greater than 0, you get two values of x, right? So that's going to be this case, two values, crosses at 2 points. Now, if del is less than 0, you're taking the square root of a negative number. That means that x is complex. Now, you may or may not have done complex numbers. You don't need it for pure 1 at all. Essentially, it means that there are no real solutions. And that means you have, if you're just looking at real solutions, which you usually are, you get this situation where there is no crossing point. So after all that, what are they asking us for? They're asking us for a value of k for which the lines cross at two distinct points. So this means we are in this regime. So we require that b squared minus 4ac is greater than 0. Well, in our case, that's k minus 2 squared minus 4 times k minus 2 is equal to is greater than 0. So let's gather the k minus 2, k minus 2 minus 4 is greater than 0. So for this thing to be greater than 0, either both of these things need to be negative or both of them need to be positive. So let me just simplify it a bit more. So if k is greater than 2, then this thing is positive. But then this thing, k actually needs to be greater than 6, because this thing also needs to be positive. So either k is greater than 6, or if k is less than 2, then this thing is negative, But then this thing is also negative. So we're fine. So this case is also fine, but nothing in between. So our condition is that k is greater than 6, or k is less than 2. That's the set of values. Question 6. So a vector, and I'm going to do my usual thing where I express vectors in these in the column notation because I find it way more easy to think about. So let's have our A, 3, 2, minus 1, and our B, 7, minus 3, 1. And they're asking us to show that something is a right angle. Now, if you see vectors and you're asked for angles, you must automatically think dot product. I mean, I've said before, I think in Monday's class, I sort of talked a bit about the dot product versus the cross product. And you will never need to use the cross product in this exam. So just think of the dot product. And the dot product defined v dot w, which you can think of as v1 w1 plus v2 w2 plus so on, which I'll define as the sum over I vi wi, just for shorthand. But it's also equal to the magnitude of v times the magnitude of w times the cosine of the angle between them. So you're using these two facts, you're equating these two things, and you can solve for the angle. So what does the cosine function look like? Well, it's like so. Now, when things are at right angles, that means that the angle is 90 degrees. So this is 360. This is 180. So this is 90. Well, cosine of 90 degrees is 0, as we can see from this graph. So if v is at right angles to w, by which I mean perpendicular with this symbol, perpendicular to w, then v dot w is equal to 0. The dot product vanishes, as they say. They're talking about the angle OAB. So if we have our O here, and that's A, and that's B. This is not accurate. I'm just sort of drawing. They're talking about this angle here. So they want the dot product between OA and AB. Well, we have OA, right? That's just A. This is the same thing as OA. But we don't have AB yet. But as I said in a previous question, AB is just equal to minus A plus B. So in this case, that's going to be equal to 4 minus 5, 2. Now I take the dot product, and this is usually represented. So I'm taking the dot product between OA and AB, and I'm going to require that that is equal to 0. In fact, no, I will show that it's equal to 0, and therefore that the cosine of theta must be 0, and therefore that the angle between them must be 90 degrees. So I'm going to talk about AB dot OA. And the way it's usually written is that you write the first one as a sort of row and the other one as column. This will become more useful in your thinking if you're planning to do matrices, because it kind of feels the same way as when you're multiplying matrices together. Don't worry if that means nothing to you. So I just sort of write it like this: 4 minus 5, 2 times OA, which is 3, 2 minus 1. And this means 4 times 3 plus minus 5 times 2 plus 2 times minus 1. What are they equal? It equals 12 minus 10 minus 2, which is equal to 0, which is equal to magnitude of A, magnitude of B, cosine theta. And then you might need to argue that magnitude of A is not equal to 0, and magnitude of B is not equal to 0. Therefore, the 0 thing must be the cosine of theta. So if A or B was 0 length, like what's called the 0 vector, then we wouldn't be able to say anything about the angle between them, which makes sense, right? I mean, it's weird talking that is just a point, like a 0 length vector. Like, what even is that? So if you're being rigorous, you might just argue that since the magnitude of A and the magnitude of B are neither of them are equal to 0, the cosine of theta must be the 0 thing. Therefore, theta is equal to 90 degrees. And happily, it's really easy because there's a right angle between them. So I'm going to redraw this in a little more familiar way. So this is A, that's B, and that's O. Well, we want the base and the height to find the area of a triangle. Well, what is the base? Well, it's just the length of this vector OA, right? So this length is OA, the length of it. And what is this height? Well, it's just the length of the vector AB. Great. So OA, well, the magnitude of a vector, this is magnitude of a vector. This is just a formula, but it's going to be equal to sort of the vector x squared, like the x component squared plus the y component squared plus the z component squared. And if there's more, if it's in like a 10-dimensional vector, like 10 things long, then you just do one for each, and then you square root it. So this is Pythagoras, right? In the same way that if you want to find this is finding the hypotenuse of a triangle, essentially. These guys are kind of I mean, if you do it visually, you'll see. I don't want to spend too much time on it, but I'm sure you've seen it before. But it's like finding the hypotenuse of a triangle, but in 3 dimensions. These guys are sort of the base, height, width, of some triangle, and then you want to find the zip right from the start point to the end point, and that length is given by this. So in this case, that's going to be the square root of plus 4 plus 1, and you do the same for AB, and that's going to be equal to the square root of 16 plus 25 plus 4. And then you just take these two and you say that the area is the 1/2 base times height. Okay, so geometric and arithmetic progressions. So I always find it useful to write out the general formula for, okay, we'll start with a geometric progression. So geometric progression is one that's characterized by the fact that if you take any piece of it, any particular term, and you divide it by the previous term, you always get the same number. It's called the common ratio. Ratio R. Now, to know the geometric progression, all you need to know is 2 numbers. You need the first number, and you need to know the common ratio, and then you can generate all the other numbers. And so this looks like this. So A, the initial first term, plus AR squared, plus AR cubed, plus blah, 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 blah. So you see that if I take any of these terms and divide it by the previous term, the A's will cancel, and almost all the R's will cancel, just leaving 1 R. So the common ratio is always R. Now, if R is smaller than 1, each power of R will be smaller and smaller and smaller. So this will be like the terms will get smaller and smaller and smaller and smaller and smaller, and they may tend towards some value. And that's it's called the convergence series. If R is bigger than 1, then each power of R is going to get bigger and bigger and bigger, and this thing is going to diverge. It's going to go to infinity, and you can't talk about a sum to infinity because infinity is not really a number, and it doesn't make any sense. But if it's convergence series, you can talk about a sum to infinity, and that's given by this formula. It's quite an interesting derivation if you ever plan to seek it out, and that's A over 1 minus R. So you're told that there's a first series, so the sum to infinity of the first series, which is A of the first series, which is A, which they told us is called A, 1 over R, and they're just calling it S. And they're saying the sum to infinity of the second series, which is the first term, which is also a, but it has the common ratio 2r, and they're saying that this is equal to 3 times s. So we have two formulas, and we need to solve. So what say we divide these by each other? So let's divide this one by this one. And we get that 3 is equal to 1 minus r over 1 minus 2r. And you can see that this can be solved for r pretty easily. Okay, so the next one is not geometric, it's an arithmetic progression. And this is a different type of progression. In these, you have a series where each term is the previous term plus some number. So it looks something like a plus I don't know, k plus a plus 2k plus so on. So you get an extra of k added for each term. So they're saying that a is equal to 7, that the nth term is 84, and the 3nth term is 245. So this is the first term, this is the second term, this is the third term. So you can see that each term, the nth term will be a plus n minus 1k. So you see that the third term had 2 values of k in it. The second term had 1 value of k in it. The fourth term will have 3 values of k in it. So the nth term will have n minus 1 values of k in it. So the nth term is 84, and this must be equal to a plus n minus 1 k. And now they're saying that 245, which is the 3nth term, is going to be 7 plus 3n minus 1 k. So we have two formulae here, and we want to solve for n. So this is not too bad. We can just divide, we can rearrange and then divide out the k. So rearrange this to be that n minus 1 k is equal to 84 minus 7, which is 77, and then 3n minus 1 k is equal to 238. And then you just divide these by each other, right? And you'll get rid of the k's. And then you can solve just for n. We have this slice. In fact, we have sort of nested slices. We have two slices, wedges, the bigger one and the smaller one. And we're also told that this A is directly above this D, with this right angle between them. Now, let's look at this triangle. It's alpha. What is this hypotenuse of this triangle? Well, it's just the radius of the big wedge, right? So that's got to be equal to 4 centimeters. And so what is the height of this AD? Well, that's just got to be 4 sine alpha, and this is going to be 4 cosine alpha. So it'll be useful to us. So the smaller segment has, if you think of just this guy, well, that has a radius here, r prime, which is equal to 4 cosine of alpha. That was just, what we worked out from this triangle. Now the arc length of, by which I mean this kind of curvy bit, the arc length is given in your formula booklet as r theta. So if it's subtended by theta, then the arc length is r times theta. So we want an expression for alpha for the perimeter, in terms of alpha for the perimeter of the shaded region. So the perimeter is going to be this. Let's do it in green. This and these two guys. Well, what are these little pieces? Well, they're just big r. They're like the r of the big piece minus the radius of the big piece minus the radius of the small piece, right? So that's 4 minus 4 cosine alpha, and there's two of those, two little pieces, plus the arc length of the bigger piece, which is 4 alpha, because the radius of the big piece is 4, plus the arc length of the smaller piece, which is going to be 4 cosine alpha, and this is equal to the perimeter. Okay, so now they've given us alpha, and they want us to find the area of that shaded region. So this is going, if you think about it, that's going to be the area of the bigger piece minus the area of the smaller piece, right? So let's first work out r prime, which we said was 4 cosine alpha. Well, if alpha is equal to pi over 6, this is equal to 2 square root 3. So you can just plug that in. And we know that the area of a wedge is 1/2 r squared alpha, where alpha is the angle. So the area we're looking for is 1/2 r squared alpha minus 1/2 r prime squared alpha, where r prime is the smaller pieces. And if you plug this in, you get that that's equal to 8 alpha minus 6 alpha, which is 2 alpha. And we know alpha, so that's just equal to pi over 3. Question 9. Here we're given a function, and we're asked to talk about it in the plane. We're given the derivative of a function, of a curve. So this is giving us the derivative of some curve. So we want the equation first of the normal to the curve. What does the normal mean? The normal is basically if you have a curve and then you have a tangent. Now the normal is the line that's at right angles to the tangent, right angles to the curve at that point. Well, what do we know about right angles in terms of these kind of like equations of lines and curves and things? We know that the gradients, if you have two straight lines that are at right angles, their gradients multiply to -1. So so if I have a tangent, if I have some point P, the gradient of the curve at P is equal to the gradient of the line tangent to the curve at P. I mean, that makes sense, right? That's what tangent means. It's kind of like you have the same gradient, the same slope at just at that moment. Then this line goes off and does its own thing. But at this moment, it is just touching the curve. So, so what is the gradient of the curve at P? Well, the gradient is given by f prime of x, right? So we just evaluate it at the x coordinate of P, which is 2. And that's going to be equal to 2 times 2 minus 2 over 4, which is going to be equal to 7 over 2. So therefore, our equation of the normal to the curve is going to have a gradient of -2 over 7 and some constant. We know that it passes through P, so we can plug in the values of P to find out what C is, right? So 6 is equal to -2 over 7 times 2 plus C, and this gives us that that C is equal to 46 over 7, which is, you know, not very nice, but what can you do? So therefore our equation of a line is y is equal to -2 over 7 x plus 46 over 7. So this is just an integration problem, and it's not too bad. So we're looking, so f of x is the integral of f prime of x dx. So we have the integral of 2x minus 2 over x squared. Well, the first one is no problem. That's going to be x squared. And the second one is going to be, so you should get used to it, but you can just think of like what's going to happen as it goes backwards. But 2 over x. So if I differentiated this, this would be x to the minus 1, so I'd get a minus out the front, and then x would go up to x squared plus c. And now I know that the point P is on this curve. So I plug in the point P. So f of 2 is equal to 6. That's the point P, which is equal to 4 plus 1 plus c. So c is equal to 1. So therefore, f of x is equal to x squared plus 2 over x plus c. So what do? We integrated. We got, for an indefinite integral, and we saw that, and then we used what's called a initial condition, or a boundary condition, really. But anyway, a condition, which gave us c. And that's always the procedure. And the x-coordinate point of the curve. So let's first just push this a little bit smaller so we have a bit more space. Okay, so stationary point, well, that's defined by f prime of x is equal to 0. So here we're going to take our f prime of x, which is what we had already. So we have that 2x minus 2 over x squared is equal to 0. And this gives us that x is equal to the cube root of 1, which is equal to 1. I mean, this is only true because x is a real number, but don't worry about it. So the cube root of 1 is always going to be 1 in real numbers. We already see that x cannot be 0 because we're dividing by it here. So this is the x-coordinate of the stationary point, but we want to find out what kind of stationary point it is. For this, we need f prime prime, and f prime prime is just 2 plus 4 over x cubed. If you differentiate that, and if we evaluate it at our point, that's going to be equal to 2 plus 4, which is equal to 6, which is greater than 0. So therefore, this point is a minimum. And that's, I'm choosing from our 3 options where f prime prime is greater than 0. Oops. That gives a minimum. F prime prime less than 0, that's a max. And f prime prime is equal to 0, well, that's a saddle point. It's more, saddle point is more complicated. I think it's just a saddle point. Yeah. Yeah. No, not a saddle point. It's called an inflection point. I think it's an inflection point. Just you don't need to know this. Forget it. You'll only need to know maxima and minima. So, oops. I can't remember what it's called. But yeah, in one of the earlier lectures, I sort of went into more detail on this. But you can just convince yourself that it's true, that the first derivative gives the slope. It's the rate of change of the x of the y coordinate of the curve with x. positive slope is increasing. A positive second derivative means that the slope itself is increasing. So if the slope is increasing at that point, it's getting steeper, right? So here it's getting shallower, and now it's getting steeper. So at that point, it's going from a slope of 0 at the very bottom, which is that f prime is 0, to a positive slope. So it's increasing. So this is a minimum versus a maximum. And you see that your slope is high, and then it gets shallower. Now it's 0, and then as it moves, it starts getting more and more negative. So it's actually at that point, it's getting shallower and shallower and shallower, and then getting more and more negative. And that counts as decreasing. Like getting more negative is decreasing. Okay. Last question. No, second to last question. So we have our very first question is completion of the square, but this is pretty easy. So if you remember, the procedure for this is you take the little bits that contain x first, and you say that x squared minus 2x, and you try and turn this into a bracket squared with a single value of x inside. So x minus 1 all squared. Well, let's check. This will give me x squared minus 2x plus 1. So I need to subtract 1 from that side. So the point is that you want to get a bracket that will reproduce these first two terms, and then you just mop up whatever extra, constant comes out the other end. You don't care. So you just look at these two guys, and then you worry about the constant later. So that means that this function that they've given us is x minus 1 all squared minus 1 minus 15 minus 16. And this is a parabola, right? Which you can see from the beginning because it's an x squared term. So now they're saying that it's defined, that its range is between c and d. So the range is like the stuff that can be output by the function. So that basically means the minimum and maximum value, depending on x. Well, what is the minimum value of this thing? It's pretty clear now that we've put it into this form that x minus 1 squared, well, this is just something squared, so this is always greater than or equal to 0. Anything squared can't be negative if you're dealing with real numbers. So the minimum value it can have, which is where x is equal to 1, is 0. Therefore, the minimum value of f of x is minus 16. There is no, the max value will be depend on what the x value is. Okay, so now they've given us this case. So we know that f of x is always greater than or equal to 9 and less than or equal to 65. So we need to know what p and q are. Well, p is going to be the minimum value of x, and if you look at f of x, say that again. So as x goes up, f of x goes up. There's no like minus sign to like make it so that they're behaving in opposite ways. If x goes up, f of x goes up. So the minimum value of f of x must be reached at the minimum value of x. Well, that's p, right? So 9 is equal to p minus 1 squared minus 16. And this will give you that p is equal to 6 or minus 4. But you can't, but the minus 4 is not allowed because this will, this is going to be outside, give you something outside the range. So yes. So now we're going to talk about the upper limit, so 65, which is going to be equal to q minus 1 squared minus 16. And this gives us that q is equal to 10 or minus 8. Yes. like that makes sense, right? Because P gives you the minimum value, Q gives you the maximum value, so X must be greater than 6 and less than 10, or greater than or equal to. Okay, last question. So this is an integration question, and it's all about, well, actually, they probably want us to do a few things first. So they want us to find alpha. Alpha is this angle. So I've got these two lines. I'm going to call this L2. I'm going to call this L1. And alpha is the angle between them. So let's look at line 1. Well, the gradient of this line is going to be the gradient of this curve evaluated at Q. So y prime, this curve, y prime is 1/2 times 4, 2 x plus 1 to the minus 1/2. So at Q, which is where the x value is 2, this is going to have a gradient of 2/3, if you plug that in. Oops, that should be a 4 in there. 4x. And the same is so our equation is y is equal to 2/3 for line 1. Y is equal to 2/3 x plus c, and we know that q is on the line, so we can go that 3 is equal to 4/3 plus c. So c is equal. Actually, you know what? We don't even need to worry about the full equation. So I'm just getting the gradient now. So what about line 2? Well, line 2, the gradient has got to be the same as this curve here, for which the gradient is a little more simple, but that's going to be equal to x. The gradient is x, so therefore the gradient at Q is 2. So now we have gradients. So gradients are just like change in y. Gradient is a change in y over change in x, right? For a straight line. That's a delta, meaning change in. And so I can use this to think about a vector that is along L1. So some vector v along L1 can be thought of as, so this is change in y over change in x, so that would work, right? Here y is changing by 2 while x is changing by 3. This vector, if I stuck it at Q, would just point along, would point along L1. And there should be some other one which is along L2, which is 1, 2. And I know that the dot product of these two things is going to be equal to the magnitude of each times the cosine of the angle. So v dot w, which is equal to 3 times 1 is 3, plus 2 times 2 is 4. And that's equal to the magnitude of v, which is the square root of 9 plus 4, 13, times the magnitude of L2, which is square root of 1 plus 4, times the cosine of the angle between them. Well, I can just then solve for alpha. So alpha is going to be equal to the inverse cosine of 7 over that square root, the other square root, and this gives us 29.7 degrees. So that was a bit challenging, wasn't it? So the thinking here was to look at these two lines, extract, so like step 1, get gradients of the lines. Step 2, turn the gradients into vectors along each line. And 3, take dot product. So the thinking here is that if I have a vector along the line and a vector along the other line, their dot product is going to be, the angle between them is going to be alpha as well. Like that's the whole point. So so therefore I can use dot product. So I generated these vectors by thinking what would get me along the line. That needed the gradient, right? Because if I have some vector which is along line L2, well then this is the delta x and this is the delta y. So I need a vector where the x sort of component divided, so the y component divided by the x component is equal to the gradient of the line. I hope that makes sense. But it was 6 questions. 6 marks, which is it's a bit of a tough question. Okay, this one is much easier, even though it's also worth 6 marks. It's one of these ones where you integrate to find area under a curve, and it's really not that hard once you get the hang of it. So once you've done some practice, so I'm going to think about the area under curve. There's this bigger area which I would get by integrating this curve, and that would give me this whole big area. And if I integrated this curve, I would get just the area under that. So the shaded area is just the green one minus the orange one, right? So my area is going to be integral of 4x plus 1 to the 1/2 dx minus integral of 1/2 x squared plus 1 dx. And I need my limits because I'm evaluating both of them between 0 and this point, which is at x is equal to 2. So 0 and 2. And the same for this one, 0 and 2. Well, this guy doesn't look like any trouble to integrate, I'm sure. But this guy is like a little more subtle. But when you get these things that are like square roots, powers to the 1/2 or 3/2 or anything like that, it's actually not that hard to integrate them. Where when there's just an x inside, there's no x squared or anything, then it gets more more difficult. But really, you can think what would give me this when I differentiated? Well, what about 4x plus 1 to the 3/2? If I did that, I would get 3/2 out the front. So I used to divide by 3/2 or multiply by 2/3. And I would also get a 4 out the front. So I want to get rid of that. So now if I differentiate this whole thing, the 3/2 will cancel the 2/3, the 4 will cancel the 1/4, and then this thing will go down from 3/2 to 1/2, and I get back that. This guy is much easier. It's just a polynomial. We know how to do that, right? So if you plug all this in, evaluate between all the limits, you get 1 over 6 on both of them, and then you get 4 times 2, which is 8, plus 1 is 9, so the 3/2 minus, and then when you put 0 in, that's minus 1, minus 2 cubed plus 2. Anyway, you get 1, which is the correct answer. And that is all there is to it. So that is actually, I think, not as hard, but you just have to think clearly about the what the areas mean, and what it means. We integrate. It's just the area under a curve. So you take that curve and you just drop down to the x-axis, and that's what you're doing when you're integrating. Well, I really hope that was helpful. I will see you next time.